Creating a cloth simulation in Blender can be an exciting and rewarding process. It all begins with setting up a simple plane as the foundation for your cloth. Once you've cleared your default scene and added a plane, scaling it to your desired size, the next crucial step is subdividing the plane. Subdividing is vital because it increases the number of vertices, which directly impacts the realism of your cloth. Adding and subdividing the plane. Blender's default plane only has 4 vertices, which isn't enough for realistic cloth deformations. When cloth interacts with other objects or folds on itself, these deformations are calculated based on the number of vertices. If you only have a few, the cloth will look blocky and unnatural. To fix this, you need to subdivide the plane. Subdividing essentially splits the plane into smaller sections, adding more vertices. To subdivide, switch to Edit mode by pressing Tab, right-click the plane and select Subdivide. In the bottom left corner of your screen, you'll see a panel where you can increase the number of cuts. The more cuts you add, the more detailed your cloth simulation will be. However, adding too many subdivisions can make the simulation slower, so aim for a balance between detail and performance. Adding a collision object. The next step involves introducing an object for your cloth to interact with. This could be a sphere, another plane, or even a complex 3D shape. The collision object serves as a surface for the cloth to drape over or fall onto, creating realistic interactions. Position this object below the plane using the Move tool. Without a collision object, the cloth would fall endlessly in the simulation, making it incomplete. To make the collision object interact with the cloth, you need to enable collision physics. Select the object, go to the Physics Properties tab, the bouncing ball icon, and click Collision. This setting allows the object to block or influence the movement of the cloth. Adjust properties like friction to control how much the cloth slides or sticks to the surface. Turning the plane into cloth. Now that your plane is subdivided and your collision object is in place, it's time to turn the plane into a cloth. With the plane selected, go to the Physics Properties tab and enable Cloth. This setting transforms the plane into a dynamic object that behaves like fabric. The cloth simulation works based on several adjustable parameters. For instance, the mass setting determines how heavy the cloth feels. Heavier cloth will drape more slowly and create deeper folds, while lighter cloth will float and react more quickly. The stiffness settings, such as bending and stretching, control how flexible or rigid the fabric appears. Experimenting with these settings allows you to achieve the exact look and behavior you want for your cloth. Simulating gravity. Blender includes real-world physics, and gravity is applied by default. This means that once you press play, your cloth will fall naturally, as it would in real life. You can adjust the gravity settings in the Scene Properties tab if you want the cloth to behave differently, such as simulating a low-gravity environment. Pinning parts of the cloth. If you want certain parts of the cloth to remain fixed in place, like the top edge of a curtain, you can pin them. This involves selecting specific vertices in Edit mode and assigning them to a vertex group. A vertex group is essentially a selection of vertices that you can apply settings to. Once you've created the vertex group, you can assign it to the pinning option in the cloth settings. This tells Blender to keep those vertices stationary while the rest of the cloth moves freely. Running the simulation. Once everything is set up, it's time to run the simulation. Press the play button and watch as the cloth falls, folds, and interacts with the collision object. If the results don't look quite right, revisit your settings to make adjustments. This iterative process allows you to refine the simulation until you're satisfied. Smoothing and enhancing the cloth. To make the cloth look smoother and more polished, apply a subdivision surface modifier. This adds additional geometry to the cloth, creating a more refined appearance. The modifier doesn't change the actual vertex count used in the simulation, but improves the visual quality of the final result.